Hello. In this lesson, we're going to check for what extensions are actually available prior to creating the instance. This will teach you also more on how fetching information from Vulkan works. I will also be using a few algorithms from the std library, but we will get to that later. First, let's start from here. In the last lesson, we had this vk result being returned from Vulkan. This result variable is returned every time we try to create something. And of course, it could succeed, but in case of an error, we can have a detailed status code. We want to check whether extensions are available before trying to create the instance. But if they're not available, we will get this extension not present. You might want to initialize Vulkan differently based on some extension being present. So let's go back to the header file, where we will create a new method called getSupportedInstanceExtensions. This method will return multiple vk extension properties in the form of a vector. And here I will also rename the above method to include instance in the name. And both of these methods are actually static. They don't require anything from the object itself, and can be invoked without Vulkan being initialized. Now, I copy the signature and create its body in the CPP file. Here Vulkan has a pattern that you will see later to repeat. If you want to fetch some information from Vulkan, like properties or devices, you should first ask it to enumerate them to get the count. So I call vk_enumerate_instance_extension_properties. Then I pass no pointer for the layer name. We will need a count variable to be initialized by the function, and finally a place to put the properties. We can create the count variable. We could theoretically also create a large buffer to hold the values and pass it in. But we have no way of knowing if that buffer space would be enough to hold the properties. This is why we just pass in the count and a no pointer. This way Vulkan will only initialize the count variable. If the count is 0, we can return an empty vector. Otherwise, we can initialize a new vector with the count size. And then call the same function again, but this time passing the vector.data. And we can finally return the properties. This pattern of first fetching the count and then actual values is common in Vulkan. So now that we have this method, we can go up here where we want to test if the suggested extensions are actually supported. First, I get the supported extension by calling the new method that we added. Then I create a new lambda, which checks if the extension name is supported. This will be true if any of the supported extensions match the given name. So here in the any_of, I will create a new lambda that checks if the given extension property's name matches the given name by using std string compare. So having this lambda, we can now test if all of the suggested extensions are also supported. If some are not, we should exit right here. And now, to better see things, I will add a breakpoint to inspect things. As you can see here, we have 18 supported extensions. And if we examine the suggested extension, we have only one. We just need the vk Chronos surface. Using debugging, you can also validate the different results that you receive. So this is it for this lesson. We currently support all the needed extensions, but this lesson showcases a very important concept in Vulkan, and that is how to get information from Vulkan. See you in the next one.